Hello, so this is A-level mathematics, and today we are going to start with March 23 paper 3 variant 2. So let's start with question number 1. So question number 1 says that it is given that x is equals to ln 2y minus 3 minus ln y plus 4. Express y in terms of x. So we have the expression x is equals to ln 2y minus 3 minus ln y plus 4. So applying ln a minus ln b equals ln a over b over here, and writing it as this form, and then applying exponential on both sides would give us e raised power x equals e raised power ln. Ln and e are anti-logs of each other, so they would cancel out. That would become 2y minus 3 over y plus 4. So cross multiplying it and taking y as the subject would give us y equals minus 3 minus 4 e raised power x over e raised power x minus 2. So this is the final answer. So question number 2 says that on an organ diagram show the region whose points represent the complex number representing the inequality. Argument of z is between minus pi by 3 to pi by 3, and real of z is less than or equal to 3. So this is angle locus. So the base starting line is this, which becomes 1 plus 2. So 1 comma 2 is the baseline, and the angles are from minus 60 to plus 60. Considering the argument, you must realize that the angles are between minus 180 to 180 degrees, and so we have to draw from minus 60 to 60, and our baseline is 1 comma 2. So 1 comma 2 is our baseline, and minus 60 to positive 60 are the lines. These are the green lines are your locus. So for real of z is less than or equal to 3, it is x is less than or equal to 3. So x equals to 3 is a vertical line. So less than or equal to 3 is the left hand side area. So the enclosed shaded area is this triangle. So question number part B says that calculate the least value of the argument z for the points in the region of A, giving the answer correct to the 3 decimal places. So we need to find the least argument of z. So least argument of z could be found by finding the point of intersection of this. So if we have this line equation, which is x is equals to 3, and we can find the equation of this line. Because the angle is negative 60, so we can deduce the gradient of this line, which is tan negative 60, which makes it minus under root 3, and the point 1 comma 2 lies on this line, so we can find the equation of this line by applying y is equals to mx plus c. So c is 2 plus under root 3, and the line L1 equation is minus under root 3x plus 2 plus under root 3. So just simultaneously solve it with x equals to 3, and which would give you the intersecting point 3 comma 2 under root 3 minus 2. So now from this point we need to find the argument, and the argument is 2 under root 3 minus 2 over 3 with the minus sign. The minus sign is because we are seeing it in the clockwise direction. So clockwise direction has a negative sign, so the answer is minus 0.454. So question number 3 says that a polynomial where a and b are constants r is denoted by p of x, where p of x is divided by this, the remainder is this. So just using the comparison method, 2x raised power 4 ax cube plus bx minus 1 could be written as it is divided by x square plus x plus 1, and an other quadratic root we do not know is cx square plus dx plus e, and the remainder was 3x plus 2, so plus the remainder. So by comparison method, we could, in comparison method, do bear in mind that first we uh, take the highest power, then we take the constant, and then we take the intermediate powers. So just compare it and you would get all of the values, and our final answer is a is equals to -3 and b is equals to 5. So now question number 4. Question number 4 is regarding complex numbers. It says that solve the equation 5z over 1 plus 2 iota minus z conjugate plus 30 plus 10 iota equals to 0. So let's assume that z is x plus iota and z conjugate is z minus iota. So we could first simplify this expression 5z over 1 plus 2 iota by rationalizing it with 1 minus 2 iota in the numerator and the denominators. So that would make up z minus 2z iota. And then we can plug in the values of x plus iota, which would give us this expression in terms of x and y. Now for z and z's conjugate, we could just multiply them up, x plus iota and x minus iota, and that would give us x square plus y square. And just plug in the values, so this would give us this final expression. Just plug in the above expression. So now the real part is also 0 and the imaginary part is also 0, and then just make it a comparison with the real part and the imaginary part, and substitute the imaginary part y is equal to x minus 10 into the expression, and you would get the final answers. By simplification, you would get a quadratic equation, and that would give you x equals to 6 and x equals to 3. We'll plug these values back into the equation and you would get y is equals to 2 and y is equals to -4. So the two complex numbers are 6 plus 2 iota and 3 minus 4 iota. You can see the question again. So question number 4. Question number 5 says that the parametric equation of a curve is t e raised by 2t and y is equals to t squared plus t plus 3. Show that dy by dx is equals to e raised to the power minus 2t. So we have to apply the chain rule. First find dx by dt by applying the product rule u dash v plus uv dash, and that becomes e raised by 2t 1 plus 2t, and then find dy by dt by simply applying the power rule of differentiation, which is 2t plus 1, and apply the chain rule. Dy by dx is equals to dy by dt into dt by dx. So dy by dt is 2t plus 1 and dt by dx is the reciprocal of this. So putting the reciprocal over here is 1 over 2t plus 1 e raised to the power 2t. So this becomes dy by dx equals e raised to the power minus 2t. So question number, the B part of it says that hence show that the normal to the curve at t is equals to -1. So at t is equals to -1, you could plug in the values in x t is equals to -1 and y t is equals to -1. You would get minus over minus e raised power minus 2 and 3. So these are the coordinates, and it says that show that the normal passes through the points in this. So first our objective must be to find the gradient of the tangent and then we need to find the gradient of the normal, and as we know the coordinate passing through the normal, which is this coordinate, we can find the equation of the normal and then we can plug in these coordinates to satisfy the equation. So that's how it's done. The tangent gradient is e square, the normal is negative reciprocal minus e raised power minus 2, the equation of the normal. We are given with the coordinates, so we can find c3 minus e raised power minus 4. The equation becomes y equals minus e raised power minus 2x plus 3 minus e raised power minus 4. And then in order for that the point passes through this tangent normal equation, it must equal itself. So it is equaling itself, so we have shown that it is passing through the above point. Question number 6 says that express 5 sine theta plus 12 cos theta in the form r cos theta minus alpha, where alpha is between 0 and 90 degrees. So r is a square plus b square, which is equal to 13, and alpha is tan inverse of b over a, so it is 5 over 12, so it becomes 0.395. So we can write it in the final form. Now it will solve the equation sine 2x plus cos is equals to 6. So just we have to replace instead of x 2x. So 2x over here and over here we have a 6, and we just need to solve a simple trigonometric equation by changing the domain, because the domain has been changed. So the final answer is 0.743 and 2.79. So question number 7 says that the diagram shows a circle with center O and radius R. The angle of the minor sector AOB of the circle is x radians. The area of the major sector of the circle is 3 times of the shaded region. Show that x equals to 3 by 4 sine x plus pi by 2. So area of the major sector is equals to 3 times the area of the shaded region. So the area of the major sector is basically half r squared theta. So the major sector is this. So this is basically 2 pi minus x. So 2 pi minus x half r squared theta equals 3 into area of the shaded region. The shaded region area is the area of the sector minus the area of the triangle. So area of the sector, which is half r square x, minus area of the triangle, which is half r square sine theta, or sine x in this case. So half r square cancels and this becomes 4 pi equals 2 pi, 4x equals 2 plus 2 pi plus 3 sine x, and x equals 3 by 4 sine x plus 5 by 2. It says that show by calculation that the root lies between 2 and 2.5. Take everything to one side. Like over here I have taken everything to x minus 3 by 4 sine x minus pi by 2 equals to 0, and replace 0 with a y, and then plug in the values. If the sign changes, that means that root lies here. The sign must change. So question number, the C part says that use an iterative formula based equation to calculate this root, cut to 2 decimal place, and use each iteration to 4 decimal places. We have taken each iteration to 4 decimal places and then seen that up to 2 decimal place 2.18 is the appropriate answer. Question number 8 says that the diagram shows the curve x cube ln x. Find the exact coordinate of m. So in order to find the exact coordinate of m, we need to find the stationary point. In order to find the stationary point, we need to take the derivative. Over here, the derivative could be found from the product rule. In the product rule, you can take anything as u and anything as v. So uv plus uv becomes x squared 3 ln x plus 1, putting it equal to 0. So we have one minimum point as 0 and one minimum point as e raised power minus 1 by 3, which is our minimum point. So finding the y coordinate of it is minus 1 over 3. So the coordinate m is e raised power minus 1 over 3 comma minus 1 over 3. So it says that find the exact shaded region bounded by the curve x-axis and the line x equals. So we need to find the shaded region. So in order to find the shaded region, we need to find this coordinate x-intercept. So it is obviously 1 because x cube is equals to 0 and ln x is equals to 0. So e raised to the power 0 is 1, so x equals to 1. So 1 is our x-intercept from this expression. So we are taking our limits from half to 1. In order to solve this is integration, and we need to apply integration by parts. In order to apply integration by parts, we need to consider that this is a strict rule to choose u as ln x, and then in the second priority take x or higher powers of x. We usually take sine and exponents as v. So the formula is u integral v minus integral v u dash. So just plug in the values and put in the limits, and you would make it equal to ln 2 over 64 minus 17 over 256. So question number 9 says that it is given that the differential equation dy by dx e raised to the power 3y sine square 2x. It is given that y is equal to 0, x equals to 0. Solve the differential equation, find the value of y when x equals to. So in differential equations, do bear in mind that the concept of differential equation itself is only 1%. The separation of variable is just the process, this step. It's just this step. And then we have the rest, which is integration and algebra. So separation of variables, e raised power minus 3y and sine square 2x. The integration of e raised power box is e raised power box over box differentiation. So e raised power minus 3y over 3 minus 3 and sine square 2x. Sine square, the integration of sine square could be from the double angle formula of cos 2x. Over here we have 2x, so cos 4x is 1 minus 2 sine square 2x. Making sine square 2x common would give you 1 minus cos 4x over 2. And doing it further would give us, I believe we have made an error here, so we could rectify that. And right over here it's 2, 2, and 2. I believe that's an error over here, so we have rectified it. And after doing the integration, so we can find c by putting in the limits, which is x y is equals to 0 and x equals to 0 would give us c is equals to minus 1 by 3. So e raised power minus 3y over 3 plus e equals to half for x minus sine 4x. So when x is equals to half, the value of y becomes 0.175. So question number 10 says that with respect to origin, the points A, B, C, and D have position vectors given by this. Find the obtuse angle obtained between the vectors OA and OB. So in order to find the angle, we need to apply the scalar product. The scalar product is OA dot OB equals OB magnitude, and cos theta. OA is 3 minus 1, 2, and OB is 1, 2, minus 3. The magnitude of OA is square root 14, and the magnitude of OB is square root 14. So this becomes 14, and this is being done by multiplying each element. 3 into 1 plus minus 1 into 2 plus minus 3 into 2 would give us as 14 as 5 minus 5, so that would give us cos theta as minus 5 over 14. So the angle taken with the negative sign would be 110.9. Do bear in mind that the question have asked you for the obtuse angle, so you need to consider the negative sign. If there is no negative sign, so that means that the angle would be acute. So it says that the line passes through the points A and B. Find the vector equation of the line. So the line is passing through the points A and B. So the gradient vector, directional vector, is AB, and the point on a line is A. So point on a line is 3 minus 1, 2, and the directional vector is AB, which could be found from OB minus OA, minus 2, 3, minus 5. Question number part C says that find the position vector of the point of intersection of line L and the line passing through. We already have the equation of line L. We need to find the equation for C and D. In order to find the equation of C and D, we need to find the directional vector CD, and we need the point C itself. So 1 minus 2, 5 plus mu, we have changed the parameter mu. First it was lambda, so 4 minus 4, 6 is the directional vector, which is CD. So just simultaneously solve both of the equations, taking the x elements 3 minus 2 lambda of this, and the x elements of this are 1 plus 4 mu, equal them, and would give us 1 is equals to lambda plus 2 mu. So equation number 2, take the y elements minus 1 plus 3 mu equals minus 2 plus minus 4 mu. So solve them simultaneously would give us mu as 2 and lambda as minus 3. Just plug in any value that any of the two would give you the point of intersection, which are 9, minus 10, and 17. So question number 11. Question number 11 is regarding partial fractions. So it says that 5x squared plus x plus 11 plus 4 plus x squared and 1 plus x. We need to express this in partial fractions. So it is one of the fraction is linear and the other is quadratic. So we can write it in a over 1 plus x plus bx plus c over 4 plus x squared. So taking the LCM, and we can just now evaluate the values of a, b, and c. In order to evaluate the values, we must first need to substitute x equals to minus 1 to find a, which gives a is equals to 3, and then we need to find x equals to 0 to find c, which gives c is equals to minus 1, and then we need to put any value from ourselves, which is x equals to 1, so would give us b is equals to 2. So that's the breakup for the partial fraction. So do bear in mind that that was a proper form, so we did not need to do the long division, because the highest power above in the numerator was 2 and in the denominator was 3. If the powers in the numerator and denominator are equal, or the numerator powers are greater or equal to the denominator, then we have to do the long division. Now it says that integrate f of x and show that it equals ln 54 minus pi. So we had two breakups just like this, 3 over 1 plus x and 2x minus. Now we need to do the working. This one over here is simple ln form, because the differentiation of the numerator 1 plus x lies above. So we could write it as 3 ln 1 plus x. So that's simple integration. Now what about this? This seems a bit complex. So we could first break it up like 2x. First we could see that is the integration differentiation of the denominator available in the numerators 2x minus 1, no, it's not available. So let's break it up. So we could write this fraction as 2x over 4 plus x square minus 1 over 4 plus x square. So now we are on the safe side because now 2x is available. So now we could write it as ln 4 plus x square. Now over here we have 1 plus 4 plus x square. 2x is not available. So what to do now? So we have uh, tan inverse differentiation. We already know that it's given in the formula sheet. Tan inverse of box is box differentiation over 1 plus box square. So now in order to do this, apply this, we need to have a 1 here. Now taking 4 common, 1 plus x square plus 4, and then taking x by 2 whole square. So the box over here is x over 2. So x over 2, the differentiation of the box must be half. So half is over here, 2 is over here. So this becomes half over 1 plus x plus 2 whole square. So now this could be written as tan inverse of x over 2. So tan inverse of x over 2, and the rest we have already done. So we have applied addition of logs, log a plus log b equals log ab, and plug in the values to give us ln 54 minus pi by 8. That was a good question considering the difficulty level. That's it for this paper. It's a special request to all the viewers to please subscribe and like the channel, and do hit the bell icon. And there are many who are watching the videos without subscribing, so it's a request to please subscribe the channel and then watch the videos. Thank you.